Hello everyone, this is Mrs. G. I'm your math instructor, and I wanted to go over literal equations. I don't know why they're named literal equations, but that's the name of it. And really what these are, it's the same processes that you've been doing for one step, two step, three step, except these are using letters instead of numerical values. So even though there's letters involved, think of it as just maybe a possible another number if that would make you understand it better. So we're going to just do some simple ones at the beginning and then we'll work our way up to some more difficult ones. So now take a look at this one. It's asking us to solve for the capital letter A. And these ones, when you do type in your answer, it does matter in Delta Math if it's a capital A, a small a. If you do it incorrectly, you make it capital when it was small, it will be marked wrong. So just be aware of what the letter is, capital or not. So think about this as needing to isolate that A, and there's a -4 plus A on this side. So I'm going to add +4 here to eliminate that on this side, which means that I need to also add it to this other side when I bring it over. So my answer is going to be A equals M plus 4. All right, now we take a look at this. We have a -b plus a equals f, and we want to solve for that small letter a. To be able to get that to the other side, I'm going to add a positive b to both sides, right? And then this becomes a equals f plus b, and that is my answer. I'm horrible at if something is capital and making it small and vice versa, so hopefully I will stay true to this as I go through these problems, but I know I really suffer on that. All right, so this one we want to solve for the small letter f, and right now it's g times f. So really you can look at this as 9 is equal to g times f if I put it in parentheses, or you could say 9 is equal to g times f. Whichever way method works better for you visually, they're all saying that it's multiplied together. So for me to isolate that f, I need to get rid of that g. So if I divide it by the capital G here, right, I'm going to cross those out. But what I do to this side, I need to do to that side. So this becomes f is equal to 9 over g. That's a 9. But maybe that confuses you when I do that. It's still saying it's 1 over g when I do that. So let's take a look at it in the way that maybe Delta Math might explain it. So right now I want to get rid of this g because I want f by itself. So I'm going to multiply this by the reciprocal 1 over g. So I do the same to this side, 1 over g. And then those g's cancel out. 9 times 1 is 9 over g is equal to g times 1. I'm sorry, f times 1. And there's that answer for that. So either I immediately divided it by g, which is essentially what I'm doing here. It's the same thing. You decide which method works for you. All right, let's go down here and solve for the capital F. And to be able to do that, I need to get rid of that small g. Remember, that's a multiplying. And I need to do the opposite order operation, which is to divide it by it. So I can either do it the way I like to do it, which is divide it by the little g's. It's the same thing. I get my answer as capital J over small g. Or if you like using those fractions the way delta shows it, to be able to isolate the f, I would need to multiply it by 1 over g, both sides to do that. And so this cancels out. And again, this leaves me a capital G over small g is equal to the large F. Same thing that we did over here. You decide which one floats your boat. All right, let's take a look at this. As I've stated in multiple times in my video lectures, Delta Math does it a little bit different maybe in how I do it. It just depends on your brain how it works. So right now I need to isolate the b, and this is really saying it's 1 over d. Over here it's saying this essentially, 1 over d times b equals 6, if you like it looking like a fraction. All right, so for me to isolate the capital B here, I like to cross multiply. So pretend that's over 1 and we cross multiply in an x fashion. So it becomes b times 1 is b and d times 6 is 6d. Or if you look at it like this, I can multiply that by little d over 1 on here to cross that out and immediately put that on the other side so you don't forget. So this gets down to b equals 6 times d. All right, let's take a look at this one. You can stop the video and see if you can solve this one. All right, hopefully you've stopped it and you solved it. I'm going to do the cross multiplying where I take this number and multiply it up here, this number and multiply it up there. So really essentially what I am saying is 6m times this 1 equals x times 12 is what I'm saying when I cross multiply. Notice I go in an x fashion starting from the denominator. So I have 6m is equal to 12x. Once I get that, I can see that there's a 6 attached to here, so I can divide each side by 6, leaving me with m is equal to 2x. And that's my answer using this method. If I do it the other way, 6m over x equals 12. I can look at that again as 1 over x times 6m. And if I take that out as its own fraction, if that's what you like, then I would multiply by x over 1 on both sides. I cancel that out here to go 6m equals 12x. I'm back up to what I did in a cross multiplying fashion. All right, and then I'm back to dividing both sides by 6 to get m is equal to 2x. All right, so those are called the literal equations step 1. All right, and then there are some practice problems. These are your practice problems and the answers will be on the following page. All right, let's take a look at the level 2 here. All right, we're still trying to isolate a letter. We're trying to isolate the A, so maybe if that helps you to kind of underline it so you know that's what you're going for. Notice that the C is attached to A, so I want to get rid of that. So I'm going to divide both sides by C. The whole thing gets divided by C. So these cancel out, but it leaves this on this side as A is equal to F minus N over C. And that is your answer. All right, let's take a look at this one. Just do it in smaller steps. You don't have to do everything in one step, but if you can do it in one step, that's fine. I want to isolate the B by itself here. And notice that the extra junk, the extra noise is this 5 and M. So remember, it's B times 5 times M. That's what all those mean when they're written like this. All right, so I want to get rid of the 5 times m, so I'm going to divide both sides by 5 over m. All right, because once I do that, I cross out the 5, I cross out the m, and I'm left with just the b over here. So b is equal to f plus 8 over 5m. You could have done that in steps if that was too much to do at one time. So maybe I want to divide this side by 5. So it becomes f plus 8 divided by 5 is equal to b times m. And then I can see I need to then divide by m, which I need to do to this side also. I'm going to put my m over here, so that cancels out. And as I've said, I like to write, you should write a number first and then your variable. It's not wrong if you do that. It's just more aesthetically pleasing like that. All right, let's take a look at this one that has a fraction to it. I like to rewrite this where my 5 is in the numerator as well as my a, and then 6 is in the denominator. That's how you write 5, 6 times a to look like that. Because if I do that, and I've done this in the 1 step, 2 steps, and other videos that I've made, I can do that cross multiplying where I'm going to take 6 times the capital letter N and then 1 times 5a. right? Because I like to get everything on one line because I don't like fractions just like everybody else. And once I get that done and I'm trying to isolate A, I can see I need to get rid of this 5. So I'm going to divide both sides by 5. And when I cancel that out, I will just have my A. And this becomes 6n over 5. And that is my answer. All right, let's take a look at this next one. The f squared, that's a squared, plus 5g equals 3md. And what am I looking for? The d. All right, so this is everything that's up here. And so for me to isolate the d, I need to get rid of the 3 and the m. So I'm going to divide it by 3m here, because when I do that, the 3's cancels, the m cancels. That means I need to do the same thing over here. If I'm dividing it by 3m, I'm going to divide it by 3m. When I put the line there, I'm dividing. So now my answer is f squared plus 5g over 3m, and that is equal to the d. All right, let's look on the next page. Again, this is the single step literal equations level 2, just some more problems. And let's see what we want. We want to have the b. So right now I have 1/4 times b. So for me to get rid of that fraction, if I do 4 over 1, right, because the 4's will cancel, you know, the 1's already do, I need to do the same thing over here. But when I do that, I am taking 4 times everything. So 4 times d minus 4 G is my answer. All right, so 4 times everything that's in here is what I'm saying I need to do. All right, let's take a look at the next one where I'm trying to determine G. So right now this is 3 plus m squared equals G over R. Remember, that means divide. And if I want to isolate the G, for me to get rid of that, I'm going to have to multiply it by R. So I'm going to have to do the same thing over here in order to cancel those out. But I'm multiplying everything by R on the side, so G is equal to R times 3 plus m squared. And that's the answer for that one. All right, so here are the answers to the single step literal equations of level 1 that were on the previous page. Let's continue on to a multi-step literal equations level 1. All right, so this is going to take more than one operation to do this. So look at this. This is GB plus NB equals 2F squared. And I want to solve for the B. Now I notice B is being multiplied by each of these. That looks like the distributive property, right? If I took the B out of everything and say, hey, B times G is GB, B times N is NB. That's correct. And then what I want to do is I want to just isolate this small b. I had to take him out of that. And so to do that, I would divide this side by G plus N. And I'm going to divide, I have to do the same thing on this side, G plus N. So when I do that, that all cancels out. And it leaves me with 2F squared over G plus N. Now, whether I put the parentheses back on it or not, that's okay. They probably won't do that in Delta Math. They'll just leave it as G plus N. Let's bounce on down to this one where I'm looking for the small g. So let me do the easier part first. This is a negative t. It could be a negative number, right? T could represent 8. Let's say a negative 8. So I'm going to add a positive t to both sides to get this to one side. And then I have u plus t. All right, I still have 4/5 times g equals u plus t. And I want to isolate the g's. So I need to eliminate this fraction, and I'm going to do so by multiplying this side by 5/4. And both of these have to be multiplied by 5/4. You can see that these will cancel out because I took this and I flipped the fraction. And when I do that over here, I'm going to write 5/4 times u plus t, and that's my answer. I either can write it like that, or I can write g is equal to 5u plus t over 4. So visually see that they're the same. Here's your 5/4 fraction. This really lives in the denominator. I'm just writing it in this way. Both are good. All right, let's take a look at this last one, and we're trying to find that small little b letter. So right away, I'm going to add plus 5q to both sides to get that on the other side. So I have 6b is equal to r cubed plus 5q. So don't get all caught up with letters and cubed, and let's just not focus on that right now. Let's just focus on they represent numbers, really. And so for me to isolate the b, you can see I need to get rid of the 6. So to do so, I'm going to multiply it by 1 over 6. This whole thing gets also multiplied by 1 over 6. When I do that, those cancel out and becomes b is equal to 1/6 times r cubed plus 5q. Or just get used to understanding that both of these mean the same thing. All right, let's go on to a little bit more challenging ones on the next page that are called multi-step literal equations level 2. All right, let's go on to the multi-step literal equations level 2. These can get quite difficult, so let's just take it a little bit at a time. All right, so right away I see that I have a plus f squared. I'm just going to get rid of that because he stands alone here, and if I add a negative f squared, that's going to eliminate that, and I'll have b over a equals 5g minus f squared. That's what I'll have. All right, so we want to get the a eventually. It is going to take multi-steps. So if I multiply a over 1 here, I do the same thing over here. That's an a, right, to this whole thing. The a's will cancel out here, and I'll have b is equal to a times 5g minus f squared. But I want a by itself. So this is junk over here now, right? I need to get rid of it. So I'm going to divide it by 5g minus f squared. If I do that and I'm dividing, it'll all come out. It'll all cancel each other. And so I need to do the same operation on this other side. So you can see these cancel out, and this is what a is equal to. B over 5g minus f squared. All right, let's move on down to this next one. Just take it slowly. Focus on the things that you can start with. I have a negative q, so I'm going to add a positive q to both sides. So n plus q equals 1/3 times t times a little baby m. Now the next thing that I want to do is I don't like fractions, so I'm going to multiply all of this by 3 over 1, which means I do the same thing over here, so I can cross those out. And this becomes 3 times n plus q is equal to capital T small m. Right, so the first thing I did was bring that q over there because it's standing alone. And then the next step I did was take care of the fraction, eliminate that. And now that I see that it's t times m, if I divide each side by a capital T, I'll be able to eliminate it on this side, leaving me m. So m is equal to 3 times n plus q over capital T. And that's the answer for this one. Let's go on to the next page, our last set of problems. All right, so this one we're trying to find the capital A. I'm going to do the first thing where I minus f on both sides. So this becomes 1/6 UA is equal to 4 minus f. I don't like the fractions, so that's going to be my next step to eliminate it. So if I multiply this whole thing by 6 over 1, I do the same thing over here. 6 minus 1, or 6 divided by 1, because I can eliminate the 6 on this side, leaving just u times a. And this becomes 6 times 4 minus f. Once I do that, I can see that I have this extra u attached to the a. Remember, that's multiplying. So I need to divide by u on both sides to be able to eliminate that u so that a is by itself. So a is equal to 6 times 4 minus f divided by that small u. These last two are more difficult, but I just put it on here in case they happen to come up in your Delta Math. And it's really good to understand this because you'll probably see this in intermediate algebra. Right now, this is a square root, and so I really can't do anything, or it's much more difficult. But let's just remember something about this. If I have a number that's squared and I want to take the square root of it, it looks like this. If I have something that's cubed, I'm going to take the cube root of it. So when I have a square root stuck underneath here, why don't I square it? Both sides, so I can get rid of that square root sign. So this becomes r squared is equal to fd plus 5g. By squaring, I have to do both sides. What I do to one side, I have to do to the other. By squaring both sides, I can eliminate the square root sign and bring it up to this. But when I do that, it's just whatever's underneath that square root becomes now exposed. All right, now that I have that, I should be able to solve it for the letter D. So I'm going to minus 5g and put that on both sides. So it becomes r squared minus 5g equals f times d. Okay, and I got to remember what I'm looking for. I'm looking for the small d. So right now, that's f times d. So I'm going to divide both sides by f, right, to get rid of that. And what I have left is d on the side. So d is equal to r squared minus 5g over f. I'm not sure if Delta Math would write it like this, but who knows? They both mean the same thing, right? I've taken the f in the denominator, moved it to the left to make it look like a fraction. It still is a fraction here, right? Its numerator is a 1. 1 is not going to impact that, but when I make it over off to the side, that's what it looks like. So just be aware, Delta may have you answer it like that. All right, our very last one here. Let's take a look at this. What do I want to solve it for? The capital letter A. So let's take a look at the first thing. I want to add a positive g to both sides so I can get rid of it on this side. So it becomes 5h cubed plus g equals ba squared. All right, I have this b times a squared. So let me isolate the a right now. So I'm going to divide both sides by the letter b. And when I do that, I have 5h cubed plus g over the small letter b is equal to a squared. Now I just want a. I don't want a squared. And that taps back into what I said here, that a squared number, you could take the square root of it. Square root, you could square it to get it back up to here. So if I just want to have a, if I take the square root, that's a square root sign, of both sides, then this becomes a is equal to the square root of 5h cubed plus g over b. And that is going to be your answer for this problem. A is equal to the square root of 5h cubed plus g over b. Thank you, everyone.